Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 3, Section 1, Part 1. And in Chapter 3, we are going to be learning about temperature and energy and heat. So specifically, 3.1 is on temperature. So some of the essential questions for this chapter are: what is temperature? Why is it important in chemistry? And how is it related to energy? So starting out with Mr. Einstein. So he has this random questions about why are milk fat particles being pushed around by water molecules? And he looked at, he's a very curious guy, like inquisitive, not weird, a little awkward, a little eccentric, I guess. But he was very inquisitive. He looked at milk under a microscope, and you can see that if you look at it 400 times, which is a lot of the magnifications of our microscopes we've looked at in biology, that those little fat particles would move. And the reason they're moving is because they're actually getting hit by vibrating, like water molecules in motion, because nothing stands perfectly still. And that's called Brownian motion. All right, I would like you to write this down, please. 3.1 temperature. So we know that matter is made out of atoms. Atoms and molecules are constantly moving. And we know that the energy of motion is called kinetic energy. And we know that kinetic energy is measured in joules. So temperature is a measure of the average kinetic energy of particles. So we know that particles are always moving, and that the average energy, kinetic energy of all those moving particles is what we measure when we measure temperature. So that's different than you normally think about it. Instead of just being hot or cold, it's how fast are the particles in the matter moving. We measure temperature in degrees Fahrenheit, and then in science, degrees Celsius, and then Kelvin. So let's talk about the size of things. When looking at the macroscopic view of things, like things you can see with your own eyes, it looks like everything just stays still. But at the atom level, we know that the little atoms in that sand are constantly moving. So you don't need to write this purple stuff down. You just need to be paying attention. So we know that some molecules have more kinetic energy than the average, and some are going to have less. That's just how averages work. So some particles are moving faster and some are moving slower, and temperature is the average of all the energy of motion of those particles. So kind of looking at temperature scales. So there's a big difference between Fahrenheit and Celsius, as you can see. 21 degrees Fahrenheit is just about 80 degrees Celsius. So knowing your temperature scales, both Celsius and Fahrenheit, are important. So looking again at the movement of atoms. So what would happen if the temperature was really, really low, and what is the lowest possible temperature? So please write this down. At absolute zero, there is no kinetic energy and the atoms stop moving. So absolute zero is the lowest possible temperature. It's theoretical. We've gotten really, really close to absolute zero, but not exactly absolute zero. And absolute zero is measured 0 Kelvin, which would be negative 273 degrees Celsius and negative 459 degrees Fahrenheit. Okay, so that would be a good thing to write down. 0 Kelvin equals negative 273 degrees Celsius, and then if you want the Fahrenheit, you can, but in science, we're just going to stick here. So how do we go back and forth between the Celsius and the Fahrenheit scales? We're probably not going to get into that equation because we're mostly going to be dealing with Celsius and Kelvin in science. So you should know, and if you don't know this, write it down, that water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. and absolute zero is negative 273 degrees Celsius. If you don't know this, that water boils at 212 Fahrenheit and 32 degrees Fahrenheit, I'm not going to test you on it. It's just a good thing to know for life. All right, you do need to write down this equation. How do we go between Kelvin and Celsius? Well, it's super easy. Instead of like the Celsius to Fahrenheit, which is like Celsius plus 32 degree Celsius temperature times 9/5 plus 32 degrees. This one is just addition, so that's super easy. Please write this down. T of Kelvin equals the temperature of Celsius plus 273. And we are going to practice this now. Okay, so we're going to go through a problem. Please write this down. Example, convert 27 degrees Celsius into kelvins. And then please write down the equation. T of K equals Tc plus 27. And then we're going to sub in our numbers. You may be able to do this in your head, but please go through and write down all the steps. So T of K is our variable. And then the Celsius temperature is 27 degrees. And then plus 273. And we get our T of K equals 300. And we don't write degrees with Kelvin, you just write K. All right, so looking at how the book went through it, and they set it up, and they got the same thing. And that concludes section 1. That was a pretty easy section.